Welcome to RCast, the official podcast of the RChain Cooperative. RChain is a complete concurrent blockchain platform designed for maximum efficiency at minimal computational and environmental costs by utilizing proof of stake. I'm Derek Barris, the Director of Content for RChain. We cover a range of topics on this podcast, from the foundations of blockchain in general to the specifics of RChain, including our foundational language, Rolang, as well as issues in calculus, governance, security, and the forthcoming businesses and dApp development on our platform. Please check out rchain.coop to learn more about our platform, as well as information on becoming a co-op member.
We were initially going to talk about the reflective proof theory stuff, which is moving along very nicely, I have to say. Since we just released with testnet 3, I wanted to talk a little bit about the main feature that got into testnet 3 and what it means for the network and how it relates to the overall arc of development. If that's okay with everyone, I'll go ahead and sort of begin at the beginning.
Cool. Yeah, sounds good.
Cool. Do you remember a while back where we sort of talked a little bit about Polkadot and some other networks and tried to do a little bit of analysis and comparison?
Yeah.
One of the things that we came up on was a guiding principle that it's all about the data. So basically the idea is that if you make a network that can demonstrably handle data, then you can specialize it to payments. But it's many times harder to go the other way around. If you make a network that's optimized for payments and then try to expand it to data, you're going to run into a lot of issues that just aren't there in payments networks.
Yeah, that totally makes sense.
If we start there, then the first thing that you want to do is you want to make a kick-ass store. That's really what it's all about. And so Ravi actually picked this up right away. If you just think about Rolang plus RSpace, this is an incredibly fancy NoSQL database. So it's a leg up on all the existing NoSQL databases because there are three things that it offers. Number one, it stores continuations, i.e. code, as well as data.
Yeah. That's
a big step forward if you want to allow for fancy things. This harkens back to stored procedures in SQL. So everybody says, don't use stored procedures. And then when they optimize their store, they end up using stored procedures. It's sort of like that, only it does it more cleanly so that you don't run into a lot of the issues that stored procedures raise for SQL databases. The other thing is that most of the NoSQL databases don't have a query language that has the semantic rigor of SQL. That's really problematic for a number of reasons that I'm sure that anyone who has used these kinds of stores in production can attest to. You don't actually know what your code will do until you run it. With SQL databases, the query language has a really crisp semantics, and so you know what your queries should do. Now, of course, the difference between in principle and in practice is often a bit of a gap. You have to account for that whenever you're building real systems. But in general, people really benefit from the crisp, well-definedness of SQL, and we offer that. So in particular, Rolang, if you look at it correctly, it's a very fancy query language. And this is because the Rolang execution semantics map directly onto the RSpace storage semantics. The two semantics are in lockstep, and this is sort of the point about correct by construction. We extract the Rolang semantics from the RSpace semantics, or vice versa. We extract the RSpace storage semantics from the abstract Rolang semantics. They're isomorphic, and because they're isomorphic, there are all kinds of advantages, such as no code injection attacks and other kinds of things. That's another benefit that you get from this very fancy store. And then finally, it offers concurrent execution. SQL offers concurrent execution as well, but the programmer has no control over the concurrency. There are no concurrency mechanisms other than locking that are directly available to the programmer. Rather than using a locking discipline, we offer the POM rule from the row calculus as the basic transactional mechanism and the basic concurrency mechanism all rolled into one. So that's the other advantage of this if you just view it as a store. So, and in fact, if you look at the development of the arc of RChain, this is the first thing we did. We built RSpace, and we built Rolang and the Rolang interpreter, and that represented one of the major releases. Not quite Node 0, but close to it. Does that make sense?
Yeah, I'd never thought about Rolang as a query language, but I guess that makes sense the way you described it. You've talked about it being a specification language before, which I thought was a really cool idea, but I'd never thought about it as a query language.
Yeah, I mean, basically, and with the pattern matching, it's very fancy query language, right? You can go into the structure of the data that's at the keys, right?
Yeah.
So it ends up being a really very powerful query language. That's the first step of development. So you can think of that as basically a standalone kind of thing. You run Rolang plus RSpace on a single computer, and then clients can go touch that store. They can use that store as a standalone instance for storing and retrieving data. The next step is to have multiple instances of these stores. Is what we're marching towards is a replicated fault-tolerant store. So we put a comms layer between two instances. And so what we choose for that comms layer is basically a state-of-the-art implementation of Kademlia that has some nice features with respect to the transport protocol that it layers over top of. But essentially, there's no rocket science there. There's no improvement or pushing forward on the state-of-the-art. It's just take that and make it work with some improvements with respect to the transport layer. Which is, again, it's not rocket science. It's just good factory and good abstraction. So that's what Rolang plus RSpace plus comms is. And that, again, corresponds to a particular release within the RChain development.
So the comms layer doesn't have anything to do with consensus, right? This is all the domain of Casper.
Yeah. Consensus is all in Casper. That's exactly right. So right now you have two instances that are connected, and if they stomp on each other or they have disagreements about source code, then that's up to the programmer to deal with.
Okay.
But that's a very good point. It segues into the next step. So the next step is you build a consensus layer. So if you want all of those instances to essentially be coordinated, so they all agree about whatever it is they're storing, then you need a consensus layer. And that's what CVC Casper is providing. For those people who haven't gone into the details of Casper, the secret ingredient to Casper is the justification structure of the blocks. Because a block, has justification pointers from previous blocks, that's how you can detect equivocation and thereby, and other kinds of things, and thereby deliver safety. That same structure is also used to impose synchronization constraints and also to impose fairness constraints. That's the distinguishing aspect of Casper that makes it perform the way it performs. Casper could be used to get consensus on anything, right? It doesn't really care what you get consensus on. Casper's role in RChain is just to make sure that all the nodes have agreement on the winners of races. And that's it. That's all that's necessary to deliver this fault-tolerant distributed computer.
Yeah, just make sure we're using resources in a consistent manner.
That's exactly right. That is precisely. So what you end up with is Rolang plus RSpace plus comms plus CVC Casper. And that gives you a distributed fault-tolerant data store. And in the world of distributed systems, that's really cool, right? That's a really cool system. Companies like SAP, they build these kinds of things and they, tout it to the world, right? SAP HANA is exactly that, but it doesn't have all the features that we've listed so far. But you couldn't deploy SAP HANA outside the firewall, right? It has to be deployed inside an organization's firewall because such a thing is still subject to denial of service attacks. Right, so someone can put a Rolang program that will go forever, or consume a bunch of storage space, or yada yada yada. There's lots and lots of ways that you could spam this network. Oh, and by the way, there's a particular release where we've got all the Casper stuff in. So all of that also corresponds to, I wish I had release numbers for this discussion, but I don't have them at my fingertips. And also I should mention that a lot of this stuff can be done in parallel. So you could do the comms layer while you're working on Rolang and RSpace, right? And you can do a bunch of Casper independent of those things. And eventually you have to assemble those parts. And so if you look at the release schedule of RChain, it doesn't exactly correspond to this linear path that I'm describing, but it's darn close.
Yeah.
But back to our denial of service issue. So what you do in order to prevent the denial of service is that you make the attacker pay to use the compute and the storage.
Right.
So you instrument the Rolang compute and the RSpace storage. As you're doing a compute step, which is a COM event, or you're doing a store step, then what you end up with is a cost for that. And so now anyone who attempts to DOS the network has to pay for the attack.
Mm-hmm.
And by the way, all of this that I've talked about, with the exception of the concurrency semantics and that sort of thing, that's all industry standard. You go to like even the Guardian's data access or Google, all of those data points are tokenized, right? Whatever they expose on the internet, you have to have tokens in order to gain access, and the tokens are limited to a certain number of requests, right? And that's before there was ever anything like Bitcoin. As soon as people started putting stuff up on the network, they were DOSed.
Yeah, and you're saying that's to prevent these DOS attacks, right?
That's right. This is all like stuff we knew for a long time. But it was the insight, the combination of taking that idea of tokenizing, online services and marrying it to the microtransaction structure afforded by, something like the blockchain. That's when you get another innovation step, because now you have a microtransactions architecture. You could imagine that the Amazon AWS engineers could have come up with this architecture.
Mm-hmm.
They're probably kicking themselves for not doing so, because the opportunity was staring in the face for the last 15 years.
Mm.
That's what testnet 3 is adding in the costing structure so that an attacker can't DOS the network. They have to pay for their attacks. The one thing that this does, though, it directly impacts or relates to the throughput of the network. So in particular, if you don't have cost accounting, then you can merge blocks that have COM events much more easily, because most of the COM events are going to be completely separate. So merging two blocks is, you just have to check and see if they don't mention the same names.
Yeah, okay. I was going to ask, by separate, you just mean they're not even competing for the same resources. They have nothing to do with one another.
Yeah. There's some subtlety there. Like you can even merge blocks that do mention the same names if they follow a particular discipline. And Mike Stay was very gracious to have analyzed all those situations. Like he basically gave this big spreadsheet of all the situations where you could potentially have conflicts and when you can safely merge blocks and when you can't. And by the way, that analysis comes directly out of the structure of Rolang. Rolang and the use of names is precisely how you can determine that you can merge blocks.
So you're talking about mergeability above and beyond something like two sends to the same name, right?
Yeah, for example. Yeah, that's correct. Yeah. It's a little bit more subtle than that. Like you have a linear send, a linear receive, and a send, which updates a value. Like when is that safe, to merge with something else? Those kinds of things.
Right.
We don't have Mike's full table implemented, and we don't have complete support in the vault structure, which is the account structure that RChain maintains to do cost accounting. And so that's being fixed so that we can separate out, like if you only have one account that everyone's depositing into, then that is a problem. But if you have an account per validator, then you have minimized a lot of the conflict.
Mm-hmm.
Right? So you can shard up the Rev Vault where we collect data that way. Those are basically sub-wallets of a larger wallet that holds all the Rev that's collected as a part of the cost accounting for client deploys. Does that make sense?
Yeah, I think so. Were you saying that there was an attack associated with that solution of separating up all of the account per user?
No, no, no. I was saying that we just simply hadn't done that
I see.
separation.
I see.
Yeah, yeah. So because of that, right now we can't merge blocks. We have to have like single parent
Yeah.
network. But as soon as we put that in and then do a little bit of other stuff, we're back to merging blocks.
Yeah. Hmm.
And then that dramatically increases the throughput of the network.
You get the increase in this throughput because you're not trying to make changes to just one account. Right now it's like you have several different accounts, and they don't even have anything to do with one another in most cases, I guess.
That's the idea. It's like you get the additional throughput because let's say that you've got some block that everyone agrees on, but two different validators are operating at different speeds, right?
Mm-hmm.
They both may build new blocks on top of that block and then submit that. And then, a third validator gets both of those blocks and says, you know what, instead of sequentializing these, I'll just merge them.
Yeah.
As long as you keep the active merging relatively low cost, if the logic starts to get really ballooned, then you have a problem, right? It's maybe just be better to sequence them. But as long as the logic doesn't balloon out of all proportion, then merging gives you much higher throughput. That's a big win. That is coming along post making it to just getting cost accounting in. We're over the hump, and now we're getting those things done, and then we start hardening. One of the things that we'll be doing is a part of the hardening is to take the RCat application, using it to drive the whole network. So one of the things that we've done is to rip off the player interface, the player client from RCat. This has a significant advantage that we can now just make a very, very simple client that just like hammers RCat requesting assets. Because RCat doesn't know what the thing on the other end is doing with those assets, right?
Mm-hmm. Mm-hmm.
Right. That gives us an ability to really be quite harsh on the network with these RCat clients, right? We can have a bunch of them and really load up the network with requests for data assets, which cycles us back to the beginning of what I was trying to say. The whole point of RSong and RCat was to demonstrate, hey, if data is king, this is the network that does data.
Mm-hmm.
And so we demonstrated that as plain as day, as clearly as you could possibly demonstrate it. So now we're going to go back to that hypothesis and say, we're driving this optimized for data, which makes it easy to do payments, but we're tackling the much harder problem.
Mm-hmm.
And so having this demonstration with RCat, and especially as a part of the hardening piece of the puzzle, will, at least in my opinion, tie a ribbon around it.
Mm-hmm.
Any thoughts? Any comments?
My understanding is that RCat is kind of like boilerplate asset management DApp that RChain wants to support as a platform. And so a lot of the hardening efforts will be to make sure that all of the features that we have do support everything that we want RCat to do, right?
That is exactly right. So our RCat is this asset management system that we sort of abstracted out of RSong. And so it's really agnostic as to what the assets you store are.
Yeah.
I'm actually hoping to do a simple little application that uses RCat, where a user uploads a picture. Did I talk about this last time? This IncMe idea?
Not with me, I don't think.
The idea with IncMe is that users can upload an avatar, a picture of themselves, and then they have exactly one action. What they can do is color other users, so they can just tag a user's profile with a color, right? So they bring up a color wheel or a box of crayons and select a color and say, right now I think you're blue, or right now I think you're red, or whatever. And you don't say what those colors mean. It's whatever people feel in the moment. And then that means that a user can also bring up their profile and see how they have been colored by the community. It may be that everybody colors them red, right? They have a sense that there's a communal consensus about red and their, and the way they've engaged the community, that they can begin to discover color and meaning. Or maybe there's a rainbow, in which case they there's a heterogeneous view of them depending on how they interact. It's a kind of game where it's not a win-lose game. It's more like, discovering what colors mean within this community. And because it's the client on this is incredibly simple, and the data assets are just pictures plus color tags, I think it can be done relatively simply, and again, provides a way to test the network. And at the same time, it could be a lot of fun for people.
So that's something that you want to deploy on testnet 3?
Probably, yeah, testnet 3, yeah. Or just after, once we get a couple of issues sorted out with testnet 3, we'll tag that as sort of a public beta, which will be the hardening piece. It's probably on that tagged network that we can build this little IncMe application.
Yeah, cool.
Yeah. It's been clear to me that not everyone has understood the arc of the development and what the design rationale is. And so I wanted to kind of put that out there and say, why things developed in the sort of shape that they did. I think there were a lot of people who were confused as to why we were declaring particular victories at particular times. And that's because they didn't have this data-centric view. And that's really what we've been going after. And ultimately, it's because, we really want to support this growing movement that people should be in charge of their own data.
Yeah, I mean, I think this was helpful for me to kind of see the bigger picture because, anybody can go and look at all of the nitty-gritty details of what was in each one of the releases of our node and kind of see the progress and the logical progression there. But it's kind of hard to put all those little pieces together and see kind of the bigger picture like you've been describing here.